looks very similar to that. Okay, let's take a look at question number 15 now. Tells you that DE is the mid-segment of triangle ABC. So let's take a look at that triangle ABC. It's not what I wanted. Triangle ABC is here. So if you're looking at ABC, you know that DE is the mid-segment of ABC. Then, the next thing we're told is that FG is the mid-segment of DBE. And then the last thing that we're told is that HI is the mid-segment of FBG. Okay, so we're going to start with then the fact that HI is 7/2. So HI is 7/2. HI is the mid-segment of triangle FBG, therefore it is half the length of FG, so therefore FG is equal to 2 times 7/2, which is 7. Then we know that FG is the mid-segment of that triangle DBE. So therefore, DE must be 14 because FG would be half the length of DE. And finally, DE is the mid-segment of triangle ABC, making the length AC equal to 28 units. Okay, the next one, you're given that the perimeter, so you have to look at that, the perimeter of this triangle SOP, so that perimeter is equal to 274. You are given the lengths of the mid-segments. So in order to solve this, you need to recall that this mid-segment is 5x minus 3. Therefore, that third side is double that, so 2 times 5x minus 3. This length WA is half the length of OS, so you need to double that. And then this length WN is half the length of SP, so double that. So the equation to solve for x is 2 times 5x minus 3 plus 2 times 3x minus 1 plus 2 times x plus 4 equals 274. That's the perimeter. So we get 10x minus 6 plus 6x minus 2 plus 2x plus 8 equals 274. So combine like terms, and you're going to get 18x plus 4 is equal to 274. 18x is equal to 270, therefore x is equal to 15. Okay, next, number 17, you're told that the given D is on the perpendicular bisector of OG. So you have the segment OG, and then you have the perpendicular bisector. So you know that the perpendicular bisector gives you congruent segments and a right angle. So if D is on the perpendicular bisector. So the point D is on this perpendicular bisector. Therefore, it's equal distance from both of those endpoints. You're given that the length DO is 2x plus 1, and the length DG is x plus 28. They're congruent. DO is equal to DG, therefore 2x plus 1 is equal to x plus 28. So x is equal to 27. Therefore, DO is equal to 2 times 27 plus 1, which is 55. Okay, let's move on to number 18. Number 18 asks you to find the distance from a point to a line. And remember, this is an equation. It's actually a formula that I gave you. There are a couple of different ways to do this. So if you don't remember the formula, that's fine. You have to at least think through the process to find this solution if you can't use the formula. So I have a point at -1, -1. And then I have this line, 3x plus 4y equals 8. So if I want to graph that, I want to put it in slope-intercept form so I can see exactly what that graph looks like. So I have a y-intercept at 2 and a slope of -3/4. So I'll go ahead and get another point and plot that line. Now I'm looking for the distance from the perpendicular distance from that line to that point. So the distance, I have to have a right angle here, is going to be that distance. In order to find that distance, you have to find that point of intersection of those two lines, then use the distance formula, or you can use the formula, the distance from a point to a line is the absolute value of a times x plus b times y plus c over the square root of a squared plus b squared. Now, the important thing to remember when you're looking at finding a, b, c, x, and y is what form this equation is in. You have to have it equal to 0, so you're going to have to subtract the 8 from both sides in order to get the correct positive or negative sign. So make sure you subtract that constant from both sides so it's set equal to 0. So now the value of a is right here, it's attached to the x, is 3. The value of b is here, it's attached to the y, and that's 4. And the value of c then is -8. The value of x comes from our ordered pair, -1. The value of y also comes from that ordered pair, -1. So now you can just substitute these values into this formula. The absolute value of 3 times -1 plus 4 times -1 minus 8 all over the square root of a, which is 3. So 3 squared plus b squared, which is 4 squared. That's going to give me the absolute value of -3 minus 4 minus 8 over the square root of 9 plus 16. That gives me the absolute value of -15 over the square root of 25. Remember, absolute value is always positive, so this becomes 15 over 5, so the answer is 3 units. This is the formula you'll need to use, or you will need to remember how to get there without the formula. So you either have to know this formula, or you have to be able to think about how you're going to find that point of intersection and then use the distance formula from chapter 1. Okay, now let's take a look at plotting some points and finding some other information. So we have the point A at -4 minus 3 minus 4. That's A. B is at 5, 4. And C is at 5 minus 4. Now we're asked, what are the coordinates of the circumcenter? So the first question you have to ask if you're looking for the circumcenter is, remember, the circumcenter is the intersection of the perpendicular bisectors. Okay, so that's an important piece of information. Then you have to ask, is this a right triangle? And the question to that, you can clearly see, is yes. So if this is a right triangle, then the circumcenter lies on the midpoint of the hypotenuse. So the circumcenter, in this case, can be found on the midpoint of the hypotenuse. Remember, that's not always going to be the case. It has to be a right triangle. So now I can find the midpoint of that line AB. I have -3 plus 5 over 2. And then I have -4 minus 4 over 2. That's going to give me 2 over 2 and -8 over 2, which gives me a midpoint at 1 minus 4. Oh, sorry, that's a plus. So that's 1, 0. That's why you draw the picture, because if it doesn't match, you can ask that question. So at 1, 0 is that midpoint of the hypotenuse, so that is where the circumcenter, or the center of the circumscribed circle, is. So remember, the circumscribed circle will go through those 3 vertices. So to find the radius of that circle, because all of those vertices are equal distance from the center, you can just use the distance formula to find the radius. So the distance from the center to a vertex is, you can pick any vertex, you get the same answer. I'm going to use A. So the center, the x-coordinate is 1 plus 3 squared, then plus 0 minus 4 squared. And I'm using that point A and that center of that circle. That's going to give me 4 squared, which is 16, plus -4 squared, which is also 16, gives me the square root of 32. Square root of 32 in simplest radical form is going to be 4 root 2. Remember, that factors to 16 and 2. 16 is a perfect square. Square root of 16 is 4. Now you are asked for the equation of the perpendicular bisector of AC. So AC is here. Because it's a horizontal line, it's pretty easy to find the midpoint of AC. you're just going to look at the horizontal change. So from -3 to 5, that average would be at 1. So the midpoint is at 1. Again, but that's a horizontal line, so the perpendicular bisector is going to end up being a vertical line that goes through that point. So you get that x is equal to 1. Okay? If you had to calculate it, you would use the midpoint formula, find the midpoint of AC, then find the slope of AC, find the perpendicular slope, and then you could get the equation of that line. But since this is a right triangle, it makes it fairly easy. Next, question 20. We did this in class, but as I said, we'll go over it again because I don't think we went over it very many times. We should probably take a look at it a couple of times. Okay, so I have the point R. The point R at -2, -3. The point A at 0, 4, and the point T at 3, -2. Sorry, that's up there. So go ahead and draw your triangle. Now remember, these are the mid-segments because these are the midpoints of the sides. So what you have are the mid-segments, and you are looking for the vertices of the triangle. This takes into consideration that you know that the length of the third side is parallel to and twice as long as the mid-segment. So if we look at RT, and we look at the slope of RT, the slope of RT is 1/5. So we know that there's going to be a line that passes through A that has a slope of 1/5. So let's just put that line there because we know it exists. We just don't know where it starts and stops. We know it's parallel. So if we use that slope, we know that it is parallel. So we have that line passes through A parallel to RT. If we look at this line RT, and we want to construct a line exactly like that, if we just use that idea of a slope and go over 5 and up 1, we'll end up right here, and that is a line that is the exact same length as RT and parallel to RT. So for that line, we just went up 1 and to the right 5. To find the other, we're going to go down 1 and to the left. So now I have two of the points I need. I have -5, 3, and I have 5, 5. So I need 3 vertices for my triangle. I have 2. So I'm going to take a look at another side, a different side this time. Let's take a look at finding the slope of, let's find the slope of AT. So the slope of AT is a negative better do this one. -2 -4 over 3 -0 gives me -6/3. So the slope of that is -6/3. I'm going to go to the side opposite AT, or the point opposite AT, which is R, and I'm going to use that slope. I'm going to go down 6 and to the right 3. So now when I draw that line that connects the point, -5, 3, it will pass through R, and land on that last vertice, which is going to be at 1, 9. So this question, when it's asking you for the coordinates of the vertices of the triangle, it's asking for -5, 3, 5, 5, and 1, 9. Those are the vertices of that triangle. And finally, the last question says, given D is the centroid. D is the centroid, so that tells you a couple of things. If it's the centroid, it's the intersection of the medians. If it's the intersection of the medians, that means each of those sides is bisected. So AE is congruent to EC, and then BG is congruent to GA, and BF is congruent to FC. And that's the information that you get from the fact that it's a median. You also know, because it's the centroid, that BD is equal to 2/3 of BE. So if you're given that BE is 63, then you know that BD is equal to 2/3 of 63, which is 42. Therefore, DE is equal to 1/3 of BE, which is going to be 21. Now you're told that AE is 13, BG is 9.5, and ABC is an isosceles triangle, and you have to determine the perimeter of ABC. So we're going to go, we know that this is 9.5. If it's isosceles, this whole side is 19. That means that this whole side would also be 19. So the perimeter is going to be equal to 19 plus 19 plus 13 plus 13. This side is 26. So that's going to give me a perimeter of 64. And that ends the quiz 5-1 to 5-3 review. I hope you got all the answers correct, and I will see you tomorrow for the quiz.